Any reproduction of this training video, in part or in whole, is unlawful and strictly prohibited without the prior written consent of VIA Graphics Corporation. Included with your videotape is a course index. This contains reference numbers which will allow you to quickly access sections and topics with ease. In order to use this, you should reset the counter on your VCR to 0 now.
The Teach Yourself series from VIA Graphics, designed to teach you to use your computer the fast and easy way.
I'm Rick Spalding, along with Paula Kennedy. Maintenance of a PC should be considered a daily, if not weekly, task.
Performing some simple maintenance tasks on our PC can help us continue to maintain our PC's maximum performance throughout its lifetime.
General maintenance can also help to provide us with vital information about the state of a system component, such as the hard drive, memory, or even impending failures of components.
Thus, a properly administered preventive maintenance program can pay for itself by reducing problem behavior, data loss, component failure, downtime, and ensuring a long life for our system.
In this tutorial, we'll cover the proper tools needed for general maintenance, perform general maintenance on our PCs, and discuss other maintenance considerations.
And finally, we'll demonstrate how to use Windows 95's maintenance software. We assume you are familiar with the fundamentals of Windows. However, if you need to review, please refer to the VIA Graphics training tutorials, learning Windows 95 or Windows 98.
PC maintenance requires some general tools. These tools are not necessarily special tools or expensive, and each of these tools can be purchased from a local hardware store.
Along with these tools, we'll need some general cleaning supplies to properly maintain our PC. These cleaning supplies can also be purchased from a hardware store or local computer store. First, we can purchase a basic tool kit from a local computer store that includes a 1/4 nut driver set, a small and medium Phillips and flathead screwdriver, a pair of tweezers, a chip inserter and extractor, a Torx driver set that includes T10 and T15 Torx bits, and some type of pliers. This basically is all that is needed for a simple set. For a fully functional tool kit, we need to include some hemostats, wire cutters and strippers, and a small flashlight.
These are the basic tools needed for maintaining and repairing PCs.
But there are a couple of more items to consider for our toolkit. These items should only be considered if we are going to perform serious PC maintenance. An ESD, or electrostatic discharge protection kit, consists of a wrist strap with a ground wire and a special conductive mat with its own ground wire. Using the ESD wrist strap and mat will help ensure that we never accidentally zap any of the components with static electricity. And in certain situations, such as repairing a broken wire, removing and installing new chips, or reattaching components to a motherboard, we must use a soldering iron to make these repairs. Although today virtually all repairs are done by simply replacing the entire failed motherboard, we may need a soldering iron in some instances.
Chemicals can be used to help clean, troubleshoot, and even repair a system. One such chemical is freeze spray. These sprays are used to cool suspected failing components quickly so as to restore them to operation.
This substance is not used to repair a device, but to confirm that we've found the failed device. Often a component's failure is heat-related, and cooling it temporarily restores it to working order. Another very useful chemical is compressed air. Compressed air is used as an aid in cleaning. Normally it is used as a blower to remove dust and debris from the keyboard and mouse.
Since we've discussed the tools for maintenance, we need to develop a preventive maintenance program that includes both active and passive preventive maintenance procedures.
Active preventive maintenance includes steps that we can apply to a system to promote a longer, trouble-free computer life.
This type of preventive maintenance primarily involves periodical cleaning of the system and all its components.
We'll discuss passive maintenance later in this tutorial, but let's explore active preventive maintenance. Remember that most systems use a forced air cooling system that allows for even cooling inside the computer. This can also be considered a dust magnet because air gets drawn into the system from the atmosphere. How often we should implement active preventive measures depends on the system's working environment and the quality of the parts. For example, if your system is continuously exposed to dust, such as a shop environment, we might have to clean this system more often than one that is in a controlled office environment. For a system that is in a very dirty environment, we should thoroughly clean it once every 3 months, while a system that is in a normal office environment can usually be cleaned once a year. The most important operation in a good preventive maintenance program is the regular and thorough cleaning of all system components. Dust buildup on the internal components can lead to several problems. Because dust builds up on the internal components, it acts as a thermal blanket, thus preventing the proper heat dissipation. Excessive heat shortens the life of system components and adds to the thermal stress problems caused by wider temperature changes between power on and power off states. Also, the dust may contain conductive elements that can cause partial short circuits. Other elements in the dust and dirt can accelerate corrosion of electrical contacts and cause improper connections. In all, the removal of any layer of dust and debris from within a computer system benefits the system in the long run. However, not cleaning a system can cause intermittent system problems, erratic operation, and eventually failure. We'll thoroughly clean our system in the next chapter. Cigarette smoke contains numerous chemicals that can conduct electricity and cause corrosion of computer parts, so we should avoid smoking near computer equipment at all times.
To properly clean a system and all the boards inside requires certain supplies along with the hardware already mentioned.
This can be pure isopropyl alcohol or acetone. Never use the store rubbing alcohol for cleaning electronic parts. It can contain contaminants like perfumes and waters that are harmful to computer components. A small brush, usually a paintbrush, can be used to carefully loosen accumulated dirt and dust before spraying with canned air. Lint-free foam cleaning swabs are used to wipe off electrical contacts and connectors, disk drive heads, and other sensitive areas. They should be made of foam or synthetic chamois material that doesn't leave lint or dust residue. A small to medium-sized vacuum cleaner with a brush attachment. A vacuum cleaner works well with cleaning a system with large amounts of dust and dirt. In the next chapter, we'll disassemble our PC and give it a thorough cleaning.
You may pause the tape now to practice on your computer.
Let's review what we've covered in this chapter. We discussed the proper tools needed for maintaining our PC, then we discussed how each tool could be used.
We discussed active maintenance, introduced a cleaning schedule, and finally we discussed cleaning supplies.
Investing in a PC is a major purchase, so why not properly maintain that investment with a good cleaning?
We clean our homes and cars, but why not our PCs? Cleaning a PC can add longevity to the use of our PC. However, by not cleaning it, we can add misery to owning one.
Since we've discussed the tools and cleaning supplies for PC maintenance, let's roll up our sleeves and get down to cleaning our PC. To properly clean a PC, it needs to be partially disassembled, but for the extremely dirty system, we may have to fully disassemble it by completely removing the motherboard. This results in the best possible access to all the areas of the system. First, we'll unplug all the cables from the chassis. Then we'll remove the case off the chassis. We simply remove the 4 holding screws on the back of our case, then gently lift the case off the chassis. Next, we need to attach the ESD wrist strap or if you don't have one, touch an unpainted surface of the chassis to remove any ESD or electrostatic charge from our body. Notice we have 2 ISA slots being used, which is slots 2 and 4, and 1 PCI slot, which is slot 3. The ISA boards are our sound card and modem, while the PCI board is our video card. We want to record the physical settings and configurations within the system, like which slot each ISA or PCI card is removed from. Now we'll remove all PCI and ISA cards that are installed. We remove the holding screws from the chassis. Then we'll remove each card without touching the connectors on the cards. Remove the COM and parallel port connectors from the chassis by removing the screws. Then unplugging each from the motherboard and removing them from the chassis. Next, we remove the HDD and IDE cables from the motherboard, then unplug them from each of the drives. Let's unplug all the power cables. First, we'll remove the power cables from the motherboard, then each of the drives. With all the cables except for the chassis display cables removed from the motherboard, we'll now remove it from the chassis. We simply remove the screws that attach the motherboard chassis to the system chassis. Our motherboard has plastic clips that can be squeezed with pliers while applying light pressure from the back. And remove the motherboard from the system chassis. Now we'll remove any SIMs or DIMMs attached to the motherboard and lay them off to the side. SIMs and DIMMs are affected greatly by static. It is a good idea to use the ESD when working with these. The SIMs or DIMMs are the memory chips installed in the motherboard. To remove them, we unlatch the latches and gently remove them from the motherboard. We are ready to remove the hard drive from the system chassis. First, we'll remove the screws that attach the hard drive to the chassis. Then we'll gently remove it from the chassis.
Now with our system disassembled, we need to properly clean and reseat each component.
One of the primary preventive maintenance functions that we can perform, since we have access to the motherboard, is to undo the effects of chip creep.
To correct chip creep, we must find all socketed components and properly reseat them.
As our system heats and cools, it expands and contracts, and this physical expansion and contraction causes components that are plugged into sockets to gradually work their way out of the sockets. This is chip creep. On our board, the only socketed chip is the BIOS, but you may have more on your motherboard. To properly seat the chip, we place our finger under the motherboard and apply downward pressure with our thumb on one end of the chip. Then move to the other side of the chip and repeat the process. If you have any other socketed chips, you'll want to also reseat them now. Since we've reseated our socketed chips that may have crept out of their sockets, the next step is to clean the system and all connectors.
Let's grab our can of compressed air, the vacuum, some cleaning solution, and the lint-free swabs.
First, we'll use the can of compressed air to blow any dust out of the power supply, especially around the fan intake and exhaust ports. This will allow the air to flow more freely through the air intake system. Then with the compressed air, we'll blow into all the PCI and ISA slots to ensure all the dust is removed. Then vacuum the motherboard. Make sure all the dust and debris is off the motherboard. Next, we'll turn the vacuum on all the system chassis. We vacuum the base and around the entire chassis, ensuring that we've done a thorough job of vacuuming it. Cleaning the connectors and contacts promotes reliable connection between devices. We'll want to clean the PCI, ISA, SIM, DIMM, and the power connectors on the motherboard. We saturate the lint-free swabs in the liquid cleaning solution, then we'll use the soaked swab to wipe the connectors clean, thus removing any dust and contaminants on these connectors. We want to pay special attention to the slot connectors on the motherboard. These slots attract dust because of the installation process of these boards. Since we've cleaned the motherboard, now we are going to clean the connectors on the plug-in boards. Here's a common mistake that we want to avoid. When the boards are handled, people often touch the connectors, coating them with oils and residue from their fingers. This will prevent the contacts from making a good connection with the motherboard connectors and eventually cause these connectors to corrode. So we want to avoid touching these connectors if at all possible. Our PC only has a sound and video card. Yours may have more cards installed. First, we'll wipe the connectors on our sound card with the cleaning solution and a lint-free swab. Now we'll wipe the connectors for our video card in the same fashion and repeat the steps with the modem. Remember that each of the drives also have connectors that need to be cleaned. Since we removed our hard drive, we'll clean its connectors first. We'll get a new lint-free swab saturated in the cleaning solution and generously wipe the connectors off. Then do the same for our floppy drive and our CD-ROM. Now that we've properly cleaned our PC, we need to reassemble it. First, we'll insert our DIMM into the socket on the motherboard. Then we'll insert the hard drive and secure it with the screws. Now attach the IDE and HDD cables to our drives. Next, we'll reattach the motherboard to the system chassis and secure it to the system chassis with the screws. Now we'll attach COM and parallel cables to the motherboard and attach the connector plates to the chassis. Next, attach the IDE and HDD cables to the motherboard. Then insert our cards into the appropriate slots. Remember, we've recorded which slots they were removed from, so if we're not sure of which slot we removed them from, refer back to the documentation, then secure them to the chassis with the screws. If your sound card had a connection to the CD-ROM, reconnect it now. With everything reassembled, we're ready to reattach the power cables for our motherboard. Remember, the black wires are always placed towards the center of the plug. And the final step is to replace the cover and secure it with the screws. Plug in the cables, and we've just performed a thorough cleaning of our PC. Refer to the PC maintenance tutorial, Doing It Yourself, if you have any questions about reassembling your PC.
There are other PC components we need to clean. For example, the keyboard, mouse, monitor, and case.
Keyboards and mice are notorious for picking up dirt and garbage because they are used more frequently than any other item in a PC. To prevent problems with our keyboard, it is a good idea to periodically clean the keyboard with a vacuum cleaner or turn the keyboard upside down and spray it with compressed air. Either method will remove the dust and debris that has accumulated inside the keyboard and help prevent future problems with keys sticking or dirty key switches. Next, we'll clean the mouse. Most mice are cleaned rather easily because they have a twist-off locking retainer that keeps the mouse ball in the body of the mouse. We'll remove the retainer and then the ball is removed. To clean the ball, we'll soak a cleaning swab in the cleaning solution and rub the ball down. Now, to clean the contact rollers inside the mouse body, we again saturate a swab in the cleaning solution and generously rub each roller until it's clean. Next, we reinsert the ball and then the retaining ring. We've just finished cleaning our PC and peripherals. To clean the case and the outside of the monitor, we can use a gentle cleaning solution like Windex. Spray some Windex in a lint-free cloth and vigorously clean the case and monitor. Passive preventive maintenance involves taking care of our system in an external manner. Basically, we need to provide our system with the best physical conditions possible. Physical conditions are the external conditions that we can control, such as ambient temperatures or room temperatures, the thermal stress from powering a computer on and off, dust and smoke contamination, and other disturbances, such as shock and vibration. Large temperature variations can lead to serious problems, so we should try to maintain the ambient temperature ranges for our computer when it's on from 60 to 90 degrees Fahrenheit and 50 to 100 degrees Fahrenheit when it's off. Also, we should never place our PC in direct sunlight because of the increase in ambient temperatures the sunlight will cause. Thermal stress is caused by powering the system on and off and will be discussed in greater detail later in this tutorial. Of course, we already know dust, dirt, smoke, and other pollutants are naughty to our system because the power supply fan carries these pollutants directly into the system and there they collect, adding to the thermal stress on our PC. We should try to avoid placing our PC in a particularly dusty area and at all costs try to avoid smoking while we're using our PC. Shock and vibration are probably the least of our worries when maintaining a PC, but they still need to be addressed. Most PCs can stand a tremendous amount of shock for a limited time, but continuous vibration can lead to a hard drive's internal components wearing out a lot sooner than normal. We should place our PC on a solid foundation where it will not be bumped or knocked over.
You may pause the tape now to practice on your computer.
Let's review what we've covered in this chapter. We disassembled our PC and then reseated the chips into the motherboard.
We cleaned the motherboard and the connectors. Then we cleaned the plug-in cards connectors and the hard drive connectors.
Then we reassembled our computer and cleaned the keyboard and the mouse.
Finally, we discussed passive preventive measures for our PC.
Diagnostic software, the kind that comes with your computer, is vitally important to us all the time.
This software can help troubleshoot a hardware problem or help maintain our system performance.
In more simple terms, diagnostic software can be the eyes through which we can examine our system from the inside.
The Power On Self-Test, or POST, is our first line of defense. POST is buried in the ROM chip on the motherboard, and whenever we start our computer, it automatically performs a series of tests that check the primary components in our system. We'll power on our computer to see the POST in operation. The POST checks the primary components on our system like the CPU, the RAM, and major peripherals. These tests are brief and do not perform a thorough test, but the post-process provides error warning messages whenever a faulty component is detected. This can be our first line of defense in the early detection of component failure. Let's face it, no matter what type of hard drive we purchase, we'll eventually have some type of problem with it, whether it's a minor or major problem.
Just consider everything a hard drive does every day. For example, if your PC is on right now, the hard drive is spinning, and because of this constant activity, our hard disk will encounter problems.
Fortunately, Windows is equipped with some various hard drive maintenance programs.
Each of these programs serves a specific function for the maintenance of our PC's hard drive.
The Scan Disk program performs a battery of tests on our hard drive, including looking for invalid file names, invalid file dates and times, bad sectors, and invalid compression structures. Then in the hard disk's file allocation table system, Scan Disk will also look for lost clusters, invalid clusters, and cross-linked clusters. Let's explore each of these terms. A lost cluster or orphaned cluster is a cluster that the FAT has associated with a file, but that cluster has no link to an entry in the file directory. Lost clusters are typically caused by program crashes, power surges, or power outages. Scan Disk fixes these errors by either deleting them or converting them to files in the drive's root folder with the names file 0000.chk, then file 0001.chk, and so on, depending on the amount of errors encountered. Then we can view these files to see if they contain any important or useful data, and we can try to salvage the data or just delete it. Invalid cluster falls under one of three categories. First, a FAT entry that refers to cluster 1 is illegal because a disk's cluster numbers start at 2. Second, a FAT entry that refers to a cluster number larger than the total number of clusters on the hard drive. And finally, a FAT entry of 0, which normally denotes an unused cluster, is used in a cluster chain. Scan Disk will ask whether we want to convert these lost file fragments to files. If we select yes, Scan Disk truncates the file by replacing the invalid cluster with an EOF marker, then converts the lost fragments to files. More than likely, we'll have to delete these files anyway instead of trying to piece everything back together. A cross-linked cluster is a cluster that has somehow been assigned to two different files, or twice in the same file. When performing Scan Disk, we are asked whether to delete the affected file, copy the cross-linked cluster to each affected file, or to ignore the cross-linked file altogether. In most cases, we'll want to copy the cross-linked file to each affected file. This way, at least one of the affected files should be usable. To perform Scan Disk, we'll click the Start button, select Programs, Accessories, System Tools, then Scan Disk, and the Scan Disk dialog box appears. Notice we have two drives listed that we can check for errors, Drive A and C. We also have two types of tests that we can perform, the standard and thorough. The standard test checks for FAT problems, invalid file names, invalid file dates and times, and compression errors. The thorough test runs the standard test and then checks the surface of the disk for bad sectors, then marks these sectors. The type of test we perform is dependent of the types of errors we are encountering. For example, if programs are opening slowly, we should consider performing the standard test. But if we are having problems recovering data that is saved to our hard drive, we should perform a thorough test. Let's select the Thorough button and notice the Options button is now available. We'll select it and the Surface Scan Options dialog box appears. The first option, the System and Data Areas, checks the entire drive for physical damage, including both the system and data areas. The second option, Test checks the system area only for physical damage. Errors in this area may indicate we should consider replacing the drive or trying some more powerful third-party software to fix these areas. And the last option, the Data Area Only, Test checks only the data area of the drive for physical damage. ScanDisk can repair errors in this area by relocating the data to a valid area of the drive and marking the bad sectors so no data will be written to these sectors in the future. The Do Not Perform Write Testing checkbox, if checked, disables the reading and writing process of ScanDisk. And the Do Not Repair Bad Sectors in Hidden System Files checkbox, if selected, keeps the hidden and system files stored in specific clusters to which they were originally written, even if the clusters are bad. We'll click Cancel to return to the ScanDisk dialog box. The Advanced Options button allows us to set ScanDisk's default settings, like whether to display a summary when finished, how to handle cross-linked files, and others. Since we haven't had any major problems, we'll select the Standard Test Radio button, then click Start. Notice as the test is performed, each part of the test is displayed. When ScanDisk completes, the results dialog box is displayed. This dialog box displays all the information about our drive, like the total disk space, number of bad sectors, to the number of bytes available in each allocation unit. Notice our drive didn't have any errors. We'll choose Close, then Close again to return to the Windows desktop. Fragmented files take longer to open and also defeat the operation of the read-ahead portion of the cache.
This is because the cache assumes that the next cluster in the chain is the one most likely to be accessed next.
If our hard drive is badly fragmented, chances are the next cluster won't belong to the appropriate file. The disk defragmenter physically reorganizes the files on the hard drive so that each file has its clusters stored continuously, thus increasing disk performance. Let's run the disk defragmenter utility. We click the Start button, select Programs, then Accessories, System Tools, and Disk Defragmenter. Then the Select Drive dialog box appears with Drive C displayed. To change the defragmenting options, we'll select the Settings button and the Disk Defragmenter Settings dialog box appears. The selected option, the Rearrange Program Files so my programs start faster checkbox, will ensure optimum performance for our hard drive. Since we've already performed ScanDisk on our drive, we'll deselect the Check Drive for Errors checkbox. And the last two options, the This Time Only or the Every Time I Defragment My Hard Drive, will determine the default settings for defrag. We'll choose the This Time Only checkbox, then OK to return to the Disk Defragmenter dialog box. To run Disk Defragmenter with the options we've specified, we click OK. The defrag process begins. As the disk defrag is doing its thing, reading and rewriting our hard drive, the dialog box shows the % complete. And depending on how fragmented our drive is and its size, the process could take a few minutes to about an hour.
You may pause the tape now.
When the disk defragmenter is completed, the Close dialog box appears, and we'll select Yes to return to the Windows desktop. We've just increased the efficiency and performance of our hard disk.
Windows 98 includes some other disk maintenance tools like Disk Cleanup and Drive Converter.
The Disk Cleanup utility helps us free up space on our hard drive by searching our hard drive and then lists temporary files, internet cache files, and unnecessary program files that we can safely delete. Let's run the Disk Cleanup program on our hard drive. From the desktop, click the Start button, choose Programs, then Accessories, System Tools, and in the flyout, click Disk Cleanup. When the Select Drive dialog box appears with our current hard drive selected, press Enter and Disk Cleanup scans the drive, checking for any files that can be safely deleted. Then, after its completion of scanning our hard drive, the Disk Cleanup dialog box appears with the folders containing files that can be deleted displayed. If we look, Disk Cleanup also shows the amount of disk space that can be freed by removing the files in each of the folders. Notice there are two other tabs besides the Disk Cleanup tab. First, click the More Options tab. Notice we have two options displayed. We can free up more disk space by removing optional Windows components or removing installed components. We're not going to use either of these options for now, but let's click the Settings tab and discuss its options. The only option available is to perform disk cleanup automatically when our hard drive runs low on disk space. We'll make sure the checkbox is checked for this option and return to the Disk Cleanup tab. Let's remove the files list in each of the folders to clear disk space. To accomplish this, we simply click OK, then press Enter. The files are removed and we are returned to the Windows desktop.
You may pause the tape now.
Let's review what we've covered in this chapter. We discussed the post and what it actually checks. Then we explored the Scan Disk program, the types of hard drive errors, and we ran the Scan Disk program on our hard drive.
We discussed the disk defragmenter program, its operation, and we ran the defrag program on our hard drive.
Finally, we explored using the Disk Cleanup utility.
That concludes this video tutorial, PC Maintenance Preventive Measures.
We've covered a lot of information in this tutorial. If you feel the need to review, simply rewind the tape and watch that section again until you are comfortable with the material.
Please feel free to contact us about our other video tutorials.
Our worldwide website address is www.viagraphics.com. Send your questions or comments on this tutorial via email to admin@viagraphics.com. For sales questions or to place an order, email sales@viagraphics.com. We at VIA Graphics would like to thank you for choosing our company for your computer training needs.
Remember, if you plan on learning PC maintenance, preventive measures, or any other computer software, there's no better way than through video training with VIA Graphics.